with a homebrew installation. And with one simple brew install minikube command, I can basically install minikube. Like this. And installed. Once minikube is installed, we want to actually start or create a minikube cluster, which is also super easy, as you see. We simply execute a minikube either as a tool for minikube driver in systems, the Kubernetes minikube installation containers, but Docker as a driver for minikube container itself. And inside minikube, we have, and for Docker already, if not, install Docker link installation, in my case, and once down, drop into them from the applications. So the download and installation may take some time. Terminal and start the minikube cluster using minikube start command, passing Docker as a driver option using the driver flag with Docker value. And let's execute. And this may also take a while when you're running it first time, because it needs to actually create the cluster and download all the necessary images and components. So the next time you do minikube start, each cluster on our machine with the latest Kubernetes version 1.22. And now we can check the status of the cluster using minikube status command. And we see that all the components inside are running and everything is configured. And now start to actually interact with our cluster using kubectl command line tool. And kubectl actually gets installed as a dependency when we install minikube, which you see right here, installing dependencies for minikube, and Kubernetes CLI is actually kubectl, and that means we already have that available, we don't have to install it. So now I can do kubectl get node, and this will display all the nodes in the cluster. In our case, we just have one node, which is control plane and the worker node at the same time, and we see information for each node, like the status, the Kubernetes version that it's running, as well as when it was added to the cluster. So with this, we now have an actual Kubernetes cluster running locally on our machine, and we can start deploying applications in it. So from this point on, we're going to be interacting with the minikube cluster using kubectl command line tool. So minikube is basically just for the startup and for deleting the cluster, but everything else, configuring, we're going to be doing through kubectl. Now we have enough knowledge to deploy a very simple but realistic application setup in a Kubernetes cluster. We will deploy a MongoDB database and a web application which will connect to the config map and the secret. And finally, we will make. So let's get right in. So I have two resources here. We're going to reference the Kubernetes documentation to create our components, which is a realistic way of working with Kubernetes, and also a Docker Hub where I have the web application. Kubernetes documentation to create our components, which is you can also let's go then and integrate we're going to create simple
Вы когда-нибудь задумывались, кто такой
.yaml. In creating a config map in Kubernetes is super simple for the. So I'm going to copy the first part here, paste it in, and that's basically the main syntax we're starting from. Let's call our config map Mongo config. So we have the metadata, and then we have the actual contents of this config map. Within the data attribute, we have all the key value pairs that we define as external configuration within this config map. In our case, we just have one, which we're going to call Mongo URL as a key. And of course, we need a value for the MongoDB URL. And the value will be the service that we're going to create for MongoDB application. And we're going to call that service Mongo service. And in a couple of minutes, you're going to see how to create this Mongo service. And that will be basically all the configuration we need for creating config map. So that one is done. Let's now go ahead and create Mongo secret.yaml, which will hold the username and password for MongoDB application. Again, to reference documentation, I'm going to take this one and let's actually copy the whole thing. So we have the secret kind instead of config map. Let's call this Mongo secret. We have type opaque, which is the generic type for defining secret data, basically. And we have the same data attribute here. And let's actually create our own values. Let's call this Mongo user and Mongo password. And as you already learned, the values in secret are base 64 and encoding values is super easy. And paste those values. Secret configuration. Any of the values defined. Again, let's create a new file, configure for put them together because all the deployments need services. So you have them grouped in one YAML file. The deployment. And as you see, deployment configuration file looks a little bit more complex than config attributes. Basically, deployment specific configuration that we have in the specification section. And let's start with the main part of the deployment, which defines the blueprint for the pods. And that blueprint is defined as a template. So template basically is a configuration of the pod within the configuration of deployment. And you see that template section has its own metadata and own spec or specification, just like deployment has its metadata and specification, right? So this part actually configures the pod within a deployment. And in the specification of the pod, we have the definition of containers. So this is a list of containers. As you learned, you can have multiple containers in a pod, but mostly one main application per pod. And this is where we define which image will be used to create this pod. In our case, this is going to be a MongoDB image. And if we search for Mongo in Docker Hub, that's basically the image name. And you can find all the tags in the tag section. And we're going to use the tag 5.0. So Mongo 5.0. That's where we define the image of the container within the pod. We can name this MongoDB. This is just the name of the container. And we also have the port where the container will listen. And let's check our image. And as you see, MongoDB starts at this port. So we can just copy it and paste it in here. So this basically just configures our deployment to create pods with a MongoDB image version 5.0. So that's the core of a deployment. Now let's see what is all this other stuff here. And then we also have match labels attribute. So what is this about? In Kubernetes, you can give any component a key value pair labels. So you can label our additional identifiers of the components in addition to the name, for example. So you can identify and address specific components using their labels. Now, what each pod will get a unique name. However, they can share the same label using a specific the pod field. For other components like deployment, let them know which pods actually belong to it. Or how does Kubernetes know which pods belong to which deployments? And that is defined using this part right here. So selector match labels is in the specification of the deployment, as you see. And this defines this selector. We have any, you can call it my key, my value, it doesn't really matter. However, the standard and a common practice in Kubernetes is to use app key to Mongo instead of label app Mongo. And let's also change this one right here to Mongo deployment. And finally, last attribute we have here is replicas, which is super simple and straightforward. This just defines how many pods you want to create using this blueprint. In our case, let's do just one replica. You should use stateful and that base print. Now let's add and section syntax, nothing service example. And you see, first let's change the name. Let's call it Mongo service. And remember, this is the end defined right here. So this is the name of the service, service specific attributes. First of all, we have the selector attribute, which you already know from here. Now, why do we need a selector in service? Because, as you know, service needs to forward the. How does service know which using should match app Mongo, and that ports configuration using and this, and we have the target port, which is the port of the target port should always be when the pod is accessible. Very target port request to the pods. And this should be same as the container port. Standard to. So let's save this, and that's our configuration for MongoDB deployment and service. Create as demo, paste everything in, and we can just adjust all this in the service and deployment, all the labels and label selectors, of course. And right here, we of course need the correct image of our web application. Going back to our Docker Hub, this is the name of my image. And again, this is public is v1.0. And there you go. So this is a very simple, that's why we need to define container port on 3000. And container port is same as target port on the service, and we can set the service port to the same value, and this will configure deployment and service function for service for any application in Kubernetes cluster, deployment components for both Mongo and web app, which are secret components. First of all, when starting a MongoDB application, we need to set username and password. So when MongoDB, and we can go, well, we variable names in most of the data question iteration. So, which is a list of environment variables with names. So this is the environment variable name that MongoDB extended for components. Under that we have, and the key which is Mongo user. So Kubernetes will basically find a secret with this name and get the value set for this key and substitute it as a value for this environment variable. And the same way, we're gonna configure the environment variable, same secret component, this time with a different key. And that's it. So our MongoDB configuration file is complete. And when it starts, a user with these credentials will be created. So we need to give this web application information about the database endpoint, where can it access the database, and which username and password to use to authenticate with the database. And I have already configured this application inside to expect. So we're going to use configuration and paste it here. And you already see an advantage of using configuration from secret or config, because if you need the same information in 10 different, and I called this one user pwd. And finally, our application needs the data URL, and this value is not in the secret but in config map. And how do we access value from config map? Very similar as the secret, so we have the same value from, and instead of secret keyref we have config map keyref, or keyref, the name of the key. And that's it. So we don't have any of else, we only have reference which makes our configuration way cleaner. Anything in our deployment base is configured before we want to be able to browse them. We will need to service configurations. Both of them are internal services. So to make it external, all we need to do is set a type, which is by default cluster IP. So that's the default type if we don't specify the type, but we're going to set it to node requires. So what is a node port? Which port, which will then is actually 32,500 bits. Now, configuration component have but there are no components inside. So first, we need to create the external configurations because they need to be there when we create those configurations. To do that, we have k8s, a Kubernetes configuration file as an input, like this. And creates whatever is defined inside. And as you see, Mongo config was created. Now let's create Mongo secret. Next, we're going to create a database and as an input. And as you see, deployment and service were created. So everything seems fine. But of course, we want to check all the pods and all the components that were created in the cluster. Switch to command line, so all, which gives you, I'm going to actually switch to command line so that we can see it better. And first, we're going to do kubectl get all, which gives you all the components created in the cluster, which includes deployments, the pods behind the deployment, and all the services. And as you see, we have Mongo deployment and web app deployment pods, each one with one replica running, and we have the services for MongoDB and web app. And web app service is of node port type, which means we can access it externally. However, we don't see config map and secret here. We can get them using kubectl get config map and kubectl get secret commands. So as you see, displaying any component is pretty easy. Using kubectl, you just do kubectl which is, this is our web application, which is connected to Shannon for a couple of. I hope I helped you learn a lot about Kubernetes.